Welcome to Trees of Treasures Woodworking Channel. My name is Dan Rossi. Today we are going to be seeing about aligning the mirrors in the cheap Chinese laser. This thing is 3.5 years old. Originally was a 60 watt laser. I converted it to a 90 watt laser. I have not touched the optics since I installed the 90 watt Reiki tube. So I'm going to show you the steps that I go through aligning lasers in commercial lasers. I'm going to try to implement them in this laser. I'm hoping it goes fast. We'll see what happens. Hopefully you pick up a couple tips along the way. And I have improved lighting and audio, so hopefully you get a much better experience. I would like to thank each and every one of you who have subscribed to my channel. Thus far, it is greatly appreciated. So let's get to it. So I already took all three of my mirrors out and my lens out, and I'm going to show you what we found here. So as you can tell, this one here is a total disaster. See if I can get a close-up of it. Not an easy task. So as you can see, this mirror is beat pretty well. And what that's from is from heat. So this is the very first mirror that comes off of the end of the laser tube. And typically in commercial lasers, every place there's a mirror, there's an air supply to it to keep it cool. And these the only place that there is any air that is supplied is at the point where it actually does the engraving on the back side of the lens and just before the nozzle. And so this is where the problem lies, is these things get hot. So that one's the worst one. I'll see if I can focus back out here. Alright, so these are the other two. There are some spots if you look real close. And so I usually buy a set of mirrors, so I buy all three of them at one time. So I'm just changing them all. I'll leave these two for emergencies in case there's an issue. I've got a backup. And so the mirrors come in the case just like this. So they tell you exactly what the size is, how many pieces there are, and what the coating is on it. So I bought two different styles. And this one is the what is this one? This is SI material, coating material, which is about the lightest duty coating there is, but it gives you real good reflective material, but protection not so much. So I mean, they work awesome, but there's issues at over longevity of them. So what I decided to go with on this particular laser was a copper mirror. So I bought two sets. I bought a copper and the other. And so here's the reflective coating on the copper, and this is the copper. So it's a solid chunk of copper. And what that does is it dissipates the heat. So I'm going to test it. We're going to see whether or not it takes care of issues with overheating the mirror. And if it does, we're good. If not, then what I'll do is I'll put an air supply on every one of the beam benders or the 90-degree angle mirrors. So you just got to make sure you put the copper on the opposite side of where the laser beam's going. So the laser beam's going to go off of the reflective coating, and the copper just dissipates the heat. So what tools do we need? So the first thing we need to do is determine the size of the mirror. And my tool of choice is the dial caliper. just because I have the dial calipers in my shop and I use them all the time, it's just easier for me. So this one does either metric or standard. This is about the only thing I use the metric for, is anything to do with these laser cutters. So we just measure it. There we go, 25.03, 24.96. So it's a 25 millimeter mirror. You just put it in there, you measure it, you're good to go. Now, you can get a pretty cheap pair of dial calipers from Harbor Freight. These ones are Matoyo, so they're a high-end dial caliper. But that's just because I do machining. So the next tool you are going to need are these split ring pliers. And they've got little tabs on here that catch the split ring. And so this is the locking ring that holds the mirror in place, and so that's what these do, is it lets you maneuver. Now these are proto, and the only reason I'm actually using those is because I couldn't find the ones that I bought specifically for my laser cutter. So that's specifically why I use these, is because I couldn't find the other ones, which are the ones I bought, which were like $5 or $4 or something on eBay. And all they are needle nose pliers with the same little tabs on them, but they're at 90 degrees, so you can get in there. It's a little inconvenient to do on your corners, but it's fine for the top one at the laser. So let's get started, and I'll show you where we're at so far. Okay, so this is my 80-watt pure Eureka tube. As you can see, the manufacturer's date is the year of 15, so this thing is exactly 5 years old, or right in that neighborhood anyway. This particular mirror here is actually good for lasers up to even 600, 800 watts, because of the heat that it can take. So that's the goal of the copper, is to dissipate the heat from the mirror. So we'll set that in. Then we'll this is the retainer. We'll put the retainer in. Now I try to wear gloves. Last thing you want to do is get your oil from your skin on it, so this just helps alleviate any issues. Now this is a little bit tricky because it's where I got it. The threads are pretty simple. There we go, now it's snug. So now it's in there, it's snug. The copper's facing the back, the mirror's facing the front, and we're good to go. If you look at this base here, this base is something that I had to machine in order to get the laser, because originally it was a 60-watt laser, and because the brackets set this thing up so high, I had to go through and raise the plane of all the mirrors all the way around to the front. So originally it starts off with the laser tube. It went through my LED diode laser, and then that shoots a beam up through here, out the other, bounces off the mirror, and goes. However, I have a tough time keeping the diodes, the diode lasers working. So I'm gonna lose this puppy. We're done with it. I'm not gonna use it, and we're gonna do it the old-fashioned way of aligning the mirrors. So now it's gonna go right from the tube, right to the first bend, and out the gate to the next 90-degree turn, and then back to the head. So we'll bring her around front, and we'll show you where we're going from there, and then I'll show you my secret weapon. One last thing I want to show you. So this is how the mirrors come. And they're all wrapped in foil. They're all wrapped individually. And so they're very well protected. So this is a company I bought them from. Co2 Lasers. Okay, so this right here is mirror number 2 spot. This is the next beam bender. So this is what the mirrors look like. They come in a foil pack, and they come wrapped in a tissue paper. Same thing, we got copper on this side and the mirrors on that side. So let me reach across here. I apologize. Okay. Now we're going to go in, put this in from the back compartment. Okay. The 45-degree angles are tough. They're the hardest ones to do, but of course they're all at 45s. Just the one at the laser head itself is a lot easier, but it's one of those things once you do it once, you're golden. Okay, just check for tightness. Okay, she's tight. I'm gonna give her a little bit more. Okay, so there's the second one. So that's how quick, simple, and easy that is. Now the same thing here. You'll see this bracket here. This metal bracket here is one I made here in the shop. So originally this thing sat down across here, and so I had to make a different 90-degree bracket in order to hold this thing so I could keep it at the same plane as the taller tube, the 80-watt tube. Okay, so I've got all of the beam benders, all the mirrors are in. So I got the mirror in the first one, in the second one. Now we're going to do the final one. So you just got to make sure, here's the copper, here's the mirror. You got to make sure the mirror is pointed in the field of the laser. So the reflective coating goes towards the laser. And all you do is just put this puppy on. And there it goes. So it clicked into a thread, so now I can just spin it right in and it'll go. I took the angle adjusters off just so they weren't going to get in my way. Come on, Pooch. Okay, so that's that. Now, if you've never done this before, so this is where the lens goes. So the lens goes here. You set it in here. This retainer holds it in place. So your focal length is between here and wherever your material is. So that is, on this particular one, originally stock is 1.5 inches. The rule of thumb is you can put any focal length you want on this thing. So if you want to do fine, they start off at about 1 inch. So 1 inch is going to give you the finest engraving. 1.5 inches is the next step up. And so I purchased I think 2.5 and a 3.5 or 3 inch, I don't know which, I can't remember which, lenses, so I could try different focal lengths. So when the focal length comes on a fine mirror, they refract close, so you got a very close tolerance on that beam when it comes out. As you get to a longer focal length, they start to bounce off like that, and the focal length, which increases your focal length, but gives you a more, I should say, a straighter cut through thicker material. So, I mean, it doesn't matter when it comes to CO2 laser cutters, height is critical. And I used to see that a lot in the filter business, because if you had a piece of material that would come down and you'd have a wave in it, it may not cut in that one spot, but if you can't cut it, you can't have it for everything. So you measure to the bed, and that's you shoot for the best, and hopefully you get it to cut enough where you can tear the material and it comes apart all right. It's a pretty common thing. And it's the same thing, you know, if you're engraving and cutting things, that it's common. So I'll give you one more pointer while I'm here. So this is the air tube that comes from the air pump that comes with the Chinese laser. And so this thing runs all the time, and what that does is it cools. I don't know if you can see it, but it cools. The tube comes in and it actually lands on the back side or the bottom side of the lens, and what that does, it keeps anything that you're burning from sticking to the lens and causing an issue being burned on the lens. So like I said before, with that first lens coming out of the tube, or I'm sorry, the first mirror coming out of the tube got super hot, and that's because it's not cooled by this. This is the only thing that air pump cools, is just this right here. Now, for anybody who cuts anything, say if you do white paper or you do cloth or anything that's white, you're liable to tarnish up. What you can do is fairly inexpensive. Instead of using the air pump, you can go to your local air gas supplier, and wherever it is in your town, whether it's air gas or whatever the company is. But what we used to use was nitrogen. And nitrogen is dirt cheap. You can get a big tank for next to nothing. There's a little rental on the tank. So you keep that in mind if that's something you actually want the rental for, because it's a month-to-month rental. It's not much, but if you're not using it, it's pointless to pay $6 or $7 a month for a tank. But the tank doesn't cost much to fill either. I mean, it used to be, it was well under $10 to fill a huge tank, which would be like a full-size oxyacetylene-sized tank. And so nitrogen is an inert gas, and that keeps the oxygen. It just kills the oxygen at the cut and above the cut, so it can't flame up. And without the flame up, you don't have any issues with scorching any of the material or anything that you're doing. So that's just a quick tip. Now I'm going to show you my secret weapon that I use for commercial lasers that don't have pointers on the back of the shutter. And I don't know if you can see this, but we've got a cross hatch in this thing, just like a gun sight. And so these are all measured for our 290s. And I've got another small one that goes inside of here, and that's got a crosshatch in it. And so this is the thinnest acrylic you can buy is what you want to do it out of, because that'll get you as close to not being off when you take it off. And so what we used to use was flame paper to align everything. The downside to using anything, I mean, originally with this one I used blue painter's tape, which works awesome. However, when you get through with it, you've got to literally rewash your mirror and wash your mirror and wash your mirror until the thing's fully aligned. And with this, you haven't got to worry, because as long as you keep your power level low, the mirror never gets touched, so nothing ever changes, so you're good to go. And you know, if you get so many pulses in here as you're adjusting, the pulses can be any place in the neighborhood. If you got too many burn holes, you don't know where it is, you pull it off, you tape another one on. So I usually do a whole nest of these things, and I just do it in RS Works or whatever the laser software is you're using. And so that's the key to success. I'm hoping. That's what my goal is. So let's get started. Okay, so all you do is you take whatever file happens to be in there. It's going to give you a number if you need to change your power, pulse, whatever. Right now I got it set for 50% power. You haven't got to go that high, but that's what I'm going to use. Just give it a quick pulse. So I did the first pulse, so now we're going to go ahead. I'm going to show you on camera what it looks like when you pulse it. And I don't know if you could see it, but I'm actually about 1/4 of an inch away from the center. And probably the reason I'm off is because, and so originally when this thing was in there, the CO2 went through that, and that whatever refraction was done with bending it naturally probably had this thing out of whack, or is probably why this is out of whack, because when I first did it, I did it with this. And because I'm not using that, now my dot is right here. It's like 1/4 of an inch off of the center hatch. Let me get in. So the good news is the levelness is right on the mark, right on the money. So what I got to do now is adjust it left to right. So I got to pull it this direction, and I'm hoping I've got enough room to do that by adjusting it. And so I got to move this whole mirror this way till we hit it on the center. So let me get started with that. Okay, so what I did was I didn't elongate these, so I couldn't move it. So what I did was I had to re-drill and tap. So I used the dial calipers and I measured the distance between, try to get these lined up on the hole now. So I measured the difference between where it tagged on the laser target and the center line, and that's what I use for my my guideline. Unfortunately, these are all stamped out boxes. It's just sheet metal, so it's not the most rigid construction, but we're not doing brain surgery either, so kind of a happy medium in between. just want it tight enough that you haven't got to worry about it vibrating loose, especially if you're wheeling it around your shop or you're pulling it out to clean behind it. Last thing you want to do is have the mirrors moving on you. So you want to make sure everything's snug without stripping out what you've tapped. Okay, so that's rigid enough. So give it another hit. See what it looks like. Hopefully we're closer. Okay, so we're going to pull this off and I'll show you where we're hitting now. So right now we're dead in the center with that spot. And that's what our goal was. So we're good. As you can see, the mirror hasn't changed any. That's still clean. And we're lined up. So now we can go ahead and put the next one on the inside. And we'll do it again. We'll bring the shuttle all the way to the back. We'll start off there, move it all the way to the front. We'll do a pulse at each end and we'll see which direction the mirror's traveling, then we'll adjust it with our pitch here. Well, as you can see, my secret weapon didn't do well. So the targets worked fine, but I don't know whether it's the mirrors or whether or not it was my setup. I had to actually relocate both of these mirrors, shim them, everything else to get them to go. So what happened was this thing was cutting so bad, I was fighting to even cut enough material. This is like 1/8 inch. So I was really hurting to get this to cut. So unfortunately, what I did was I started off with electrical tape because that's what I had in the shop. Today I had to run to Home Depot because the girlfriend wanted to paint a room, so I picked up some painter's tape, what I used to use. And I just got miles and miles and miles of this stuff here. Just trying to get it close. So right now I'm pretty much on target between this side over here and that side. They're just about dead on with one another. Now as you can see, this plate here, see if I can get a close up here. So this plate here is thin, and I had to readjust it, but it's not simple because the metal was so thin. I ended up having to put nuts on the back side, and it just makes for a very unfriendly application, that's for damn sure. So I don't know, you can see so these are the targets going across. So I used tape, but then I also put the targets in here and locked them in just to make sure we were close. And that right there, that was down here from the beam bender down. So I'm going to give it a go, see whether or not it does anything. I'll bring up this file here. So what I did was I purchased another 1.5 inch focal length as what this was originally. I purchased another one. So I'll bring this thing up. And I don't know, so I lost my little measuring tool many moons ago. So I measured it with the dial calipers. And with the dial calipers, it looks to be, it's pretty damn close to 1/4 of an inch to bring that in focus length at the surface. So we'll bring it up. I'll connect the file. This is just a scrap piece I'm trying here because I don't want to ruin a part. And all it does is it just engraves a number, a part number, so the service techs that install them, they've got hundreds of different ones, and they're all shaped a little bit different. So this is like a dream come true landing this job, because I mean, like this week they released 3 different sets of 16 pieces each. Sometimes I get as much as 24, I've even had full sets. So I did a set a week before with a full set of like 54 pieces, and I charge them just to cut them or machine them and put the countersink. For these 2 holes, I gotta have a countersink, and then I engrave them. And with that, I charge them $17, which is about 1/3 of what the machine shop that was making them charges them, but still profitable for me, and it keeps them from going back to them. So they're always knocking on my door for more parts. So let me see if I can find a file I got to do. Okay, so this is one of them. We'll give her a go, see what happens. Well, that's a good sign. At least it's cutting. Okay, so I don't know if you can make it out, but that's the serial number. Boy, that is hard. Maybe I don't know if I can get it close enough. Got enough lights in here. It's hard to get the focus. There we go. So that's the serial number, and that's all I do. I engrave that on every part. So before, this thing looked like hell. So the moral of the story is, if I didn't, I would have went a lot deeper with this. But because I need this thing to run, I've got to have these serial numbers. I sent 2 batches out this week with with Sharpies written on them, because I didn't have this thing running. I took it apart last weekend. So, and because the focus was off so far, I didn't feel confident enough to even attempt to go anywhere, because I didn't want stray beams any place in this shop and shooting myself with the darn things or burning something up. So, but we're pretty close now. So, I mean, you just got to know with these things that everything is so light duty that the mirrors they're flimsy. You know, the holders, the pedestals, all that. So it takes time. I mean, honest to God, I bet you I probably had 4 hours invested just getting this mirror to this point, because it was so far off. I tagged it here. I was dead center here. From back there, no problem. That didn't take me any time at all. But from here to here, let me move this down. From here to here, I was no place in this 18 millimeter circle here. I mean, I was hitting, it was so far off I couldn't even see it on the tape. I put a full width tape here, and that's how far it was shooting that beam off. Not changing anything but the mirror. So I don't know whether it's the quality of the mirrors or that much different. I don't know what it was. But, I mean, I knew I had adjusted that one majorly, but I was hitting the center of this one. I didn't think this one was off. So, but we're all back in action. We're back going. Thanks for watching the video. And let me give you one more tip while you're here, since you took the time to watch the video. So you can use any lightweight oil. This here is actually pump seal oil that I use on my my spray gun. I got a spray gun that uses a spray piston to pump the paint, so I haven't got to reduce it, and the lacquers. So all you have to do is just put a bead of this lightweight oil on here. You know, I would do it at least once a week if you're using it, or if you're not using it once a week, before you use it again, just pop that on there, oil it, kind of rub it on the, what I usually use is a paper towel, and I rub it, and then rub it off, because these bearings, you got to keep them lubed up. And I don't notice it so much in the summertime, but in the winter when it starts getting chilly in here, same thing here. Now you can use gun oil, you can use sewing machine oil, any lightweight oil will work. Just make sure you give them a batch, and then just jog it back and forth, and it'll keep them running for years. And that's it. Thank you very much.